Welcome to Spring LIB.
Got to draw some reaction arrows here, or fishhook arrows, right? So we've got a methyl cyclohexane radical and HBr. And we're going to end up with hydrogen on the methyl cyclohexane radical. So really all you need to do is draw a single fishhook arrow from your radical to somewhere in space, and then draw another single fishhook radical arrow that meets it, typically from a bond going through homolytic cleavage. So check this out. This is just going to go somewhere, doesn't matter where. And then we draw another fishhook arrow coming from a bond or perhaps from another radical that meets it, like so, right? And then we just put this other remaining electron on the bromine. And that's the pattern. From the radical into space somewhere, meet it with an electron from a lone pair or a bond, and then the remaining electron needs to be put somewhere else, and that will give us the correct product. Okay, let's continue. So this time the radical is on the bromine. So I like to start from where the radical is, just somewhere into space. And then from a bond, in this case it's the double bond that's breaking, so we'll show a fishhook arrow coming from the bond to meet that in space. And then we know that the remaining electron has to end up on this tertiary carbon, so we'll do that. And now we've broken the double bond, which leaves a single bond and a radical, as well as a carbon-bromine bond. All right, let's continue. This time we've got two radicals coming together. Doesn't change anything. We still just start from some radical and go somewhere in space, and then from the other radical we meet it. Okay, what else? What's next? We got another one with bromine. This time the bromine is the radical. Somewhere in space, come and meet it. And then we will push the... Wait, what's going on here? Oh, I see. I got the wrong idea about this one. I did not look at the product first. Let me step back there. Okay. So in this case, the bromine is simply abstracting a hydrogen, but the hydrogen's not shown. So we've got to draw it in. And that's going to make it a little tricky, but not impossible. I guess technically it's on the top, so let me redraw that. Okay, same idea though. We'll start from the radical, somewhere in space, and then we'll go from the carbon-hydrogen bond to meet it in space, and then the second one will remain on the carbon. Right, the double bond wasn't involved. All right, two more. Okay, and in this case, I guess this is a little different. We are going to form a double bond and break a single bond. All right. So we're still going to start from the radical, but now instead of going somewhere into space, we've got to go to the double bond that we're forming, right? So like we know that we should end up with a double bond between these two carbons. So I'm going to come from the radical to that double bond. And then I've got to find another radical or bond that could split into radicals under homolytic cleavage to form the rest of that double bond. It's going to be this neighboring bond here, because that's also the bond we're breaking. And then we know that the other half gets left behind on this carbon. Oh, that's the radical side. And then this is the double bond side. Okay. finally, we're just doing homolytic cleavage here. So when we're doing homolytic cleavage, all we have to worry about is breaking a bond one electron at a time. So one electron will go over here and one electron will go over here. We'll get two of these. All right. Chlorination of methylene chloride. This is a long one. Okay. The methylene chloride, that's going to be with the radical, and then we've got chlorine and chlorine. Like so. Chlorination of chloroform to produce carbon tetrachloride. Okay, so now we've got CCl3. This is going to be a longer mechanism. We've got to lose the hydrogen, so that's chloroform, and we need chlorines. Right, so we can show okay. It's going to make HCl and our radical. Oop. Scroll down a bit. And then we're going to have our Cl radical. And let's say we lost HCl because we formed HCl, so just so we don't have to keep tracking it, and then these will come together. Great. All right, chlorination of ethane to produce ethyl chloride is going to proceed much the same. In much the same way. Okay, we're going to form HCl. We'll say minus HCl, so we can ignore the HCl we generated. Got our chlorine radical. And there we are.